out beyond Neptune, past the orbit of Pluto, in one of the coldest and darkest regions of the solar system, astronomers have found something that should not be there. An atmosphere. Not around a giant planet, not around a world like Earth, not even around something the size of Pluto, but around a tiny frozen object only about 500 kilometers wide. That is smaller than many moons, smaller than many objects scientists would normally expect to be active, and yet, somehow this distant world appears to be holding on to a thin layer of gas. And that is where the mystery begins. Because according to what scientists thought they understood, a world this small, this cold, and this far from the sun should not easily keep an atmosphere. It should be too weak, too frozen, too inactive. Its gravity should be too small to hold on to gases for long. Any atmosphere should either freeze onto the surface, drift away into space, or disappear after a short time. But when astronomers watched this tiny world pass in front of a distant star, the light did not simply blink out, it faded in a strange way. And that faint fading may have revealed something enormous, a hidden atmosphere on one of the smallest worlds ever seen with one. The object is called 2002 XV93. That name may not sound dramatic, but this tiny icy body sits in one of the most mysterious neighborhoods in the solar system, the Kuiper Belt. The Kuiper Belt is a vast frozen region beyond Neptune, filled with ancient leftovers from the birth of the solar system. These objects are like cosmic fossils, preserved in deep cold for billions of years. Most of them are dark, frozen, silent, nearly impossible to study in detail. But every now and then, one of them gives scientists a brief chance to look closer. That chance came during a stellar occultation. This happens when a small object passes directly in front of a distant star from our point of view on Earth. For just a few seconds, the object blocks the star's light. To most people, that sounds simple. A tiny world crosses a star, the star disappears, then it comes back. But to astronomers, this is one of the most powerful ways to study objects that are too small and too distant to image directly. If there is no atmosphere, the star's light should drop sharply, like someone turning off a switch. But if there is an atmosphere, the light changes differently. It fades gradually. The gas around the object bends, absorbs, and softens the starlight before the solid surface blocks it completely. And that is exactly what caught scientists' attention. The starlight did not behave like it was being blocked by a dead, airless rock. It behaved like it had passed through something. Something thin, something delicate, something wrapped around this tiny, distant world. The atmosphere, if confirmed, is unbelievably faint. Not like Earth's atmosphere, not even close. Earth's atmosphere is thick enough to create weather, clouds, storms, winds, and pressures strong enough for life as we know it. This atmosphere may be millions of times thinner. In fact, scientists estimate it could be about 5 to 10 million times thinner than Earth's atmosphere. That sounds almost like nothing. But in the outer solar system, even almost nothing can be a scientific earthquake, because this is not supposed to happen on such a small body. For years, the known examples of atmospheres beyond Neptune were linked to larger worlds, especially Pluto. Pluto has a fragile atmosphere made mostly of nitrogen, with traces of methane and carbon monoxide. It expands and collapses as Pluto moves through its long orbit around the Sun. But Pluto is much larger than 2002 XV93. Pluto is more than 2,300 kilometers wide. This newly studied world is only about 500 kilometers across. That difference matters. The smaller a world is, the weaker its gravity tends to be, and weak gravity makes it difficult to hold on to gas. So if 2002 XV93 really has a global atmosphere, scientists have to explain how it got there and how it survived. There are two major possibilities. The first is violent, a collision.
Imagine another icy object slamming into 2002 XV93 somewhere in the distant past, or maybe even relatively recently in cosmic terms.
The impact could have released frozen gases trapped beneath the surface. Methane, nitrogen, carbon monoxide. In the extreme cold beyond Neptune, these substances can exist as ice, but after an impact, they could be blasted upward, creating a temporary shell of gas around the object. In this version of the story, the atmosphere is not permanent. It is a wound, a fading trace of a collision that disturbed a frozen world and briefly gave it a breath of gas.
If that is true, the atmosphere may slowly disappear over time. Future observations could show it fading. And if it fades, scientists may have caught something incredibly rare, the aftermath of a cosmic impact on a tiny world billions of kilometers away.
But there is another possibility, and it may be even stranger. Cryovolcanism. That means ice volcanoes, not volcanoes that erupt molten rock like on Earth. Ice volcanoes erupt volatile materials, gases, slush, or icy compounds from beneath the surface. On worlds far from the sun, rock is not always the main actor. Ice can behave like geology. Frozen methane, nitrogen, carbon monoxide, ammonia, or water-rich mixtures can move, fracture, and erupt under the right conditions. If 2002 XV93 is still releasing gas from inside, that would mean it is not just a dead frozen chunk. It could still be active, and that would be astonishing, because this object is ancient. It likely formed around the same time as the rest of the solar system, more than 4 billion years ago.
If it still has enough internal activity to feed an atmosphere, then scientists may have underestimated how alive these tiny outer solar system worlds can be. That changes the story of the Kuiper Belt.
For a long time, many people imagined this region as a distant graveyard of ice, a place where ancient objects simply drift in darkness. But discoveries like this suggest the Kuiper Belt may be more dynamic than expected. Tiny worlds may not be as simple as they look. Some may have hidden layers. Some may have buried gases. Some may have internal heat. Some may erupt. Some may briefly grow atmospheres and then lose them again. And the most incredible part is that we are only seeing hints. 2002 XV93 is so distant that even our best telescopes cannot easily show it as a detailed world. At the time of the observations, it was billions of kilometers from Earth. From here, it is not a planet with visible landscapes. It is a tiny point of light moving slowly through the darkness. And yet, from a brief dimming of a background star, scientists may have detected the invisible outline of an atmosphere. That is the power of astronomy. Sometimes the universe does not announce its secrets loudly. Sometimes it whispers through a fraction of lost starlight. For a few seconds, a distant star faded. And hidden in that fading was a clue that may force scientists to rethink what small worlds can do. But there is one important question. Is this atmosphere real? The evidence is strong enough to be exciting, but scientists still need confirmation. That is why future observations matter. If astronomers can watch 2002 XV93 during another occultation, they may be able to see whether the same pattern appears again. If the atmosphere is still there, that could support the idea that something is replenishing it. Maybe internal activity. Maybe slow seasonal changes. Maybe cryovolcanism. But if the atmosphere weakens or disappears, that could support the impact theory. A temporary atmosphere, created by violence, caught in the act of fading away. The James Webb Space Telescope may also help by studying what the gases are made of. That would be crucial. Because different gases tell different stories. Methane could point to one kind of surface chemistry. Nitrogen could connect it to Pluto-like processes. Carbon monoxide could reveal another kind of volatile cycle. The composition could tell scientists whether this atmosphere is ancient, temporary, seasonal, or actively renewed. And that is what makes this discovery so powerful. It is not just about one tiny world. It is about a bigger question. How many other small worlds are hiding atmospheres?
If 2002 XV93 can have one, maybe it is not alone. Maybe the outer solar system contains many icy objects that briefly breathe.
Maybe atmospheres are not as rare as we thought. Maybe tiny worlds can wake up after impacts, erupt from within, or change with the slow rhythm of their orbits. And if that is true, then the Kuiper Belt is not just a museum of frozen leftovers. It is a laboratory, a place where ancient materials still interact, shift, escape, freeze, and transform. This also tells us something deeper about the solar system itself. The planets we know are only the obvious part. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune are the main characters we learned about. But beyond Neptune, there are thousands of smaller objects. Some are dwarf planets. Some are icy bodies. Some are fragments from the earliest days of the solar system. And because they are so far away, they have kept many of their secrets. Every discovery out there is like opening a time capsule. The chemicals on these worlds may be the same ingredients that existed when the planets were forming. So when scientists find an atmosphere on one of them, they are not just studying gas, they are studying history. The history of frozen materials, the history of impacts, the history of planetary formation, the history of how small objects evolve in deep space. And 2002 XV93 may now become one of the most important tiny worlds in the outer solar system. Not because it is large, but because it broke expectations. It reminded scientists that size is not everything. A world can be small and still be complex. A world can be frozen and still be active. A world can be distant and still change what we know. And that is why this discovery feels almost impossible. A tiny object beyond Neptune, wrapped in a ghost-like atmosphere, drifting through the dark at the edge of the solar system. It is not a place we can visit tomorrow. It is not a world we can see with our eyes. But for a brief moment, it passed in front of a star, and in that moment, the star's light revealed something hidden. A thin atmosphere. A scientific puzzle. A clue that the outer solar system may be far stranger than we imagined. The next question is not just whether 2002 XV93 has an atmosphere. The next question is how many other tiny worlds are breathing in the dark, and we simply have not caught them yet.